in your exam, final exam, and how many classes do we need and how we'll be going about. So firstly, we have the first book. You would require two books here, book 1 and book 2. Both the books are there. So NCERT textbooks you should have, and if you require any book, the operations team is there. They can provide you with the soft copies. So currently we'll start with the first chapter, physical world. But before that, I want you both to let me know how much portion has been completed in your school only. Fairs, can you let me know?
Ma'am, in my school, they started from units and measurement,
And how much
and
has been completed?
they finished the first chapter, the units and measurement, and the motion in the straight line. They finished half.
Okay, half in the motion. Straight line. Okay, okay, fine. And what about you, Tayyabullah?
Yes, ma'am. The first chapter is done, and second is done half, and the third is done 3/4.
Third has been started without the completion of the second one.
Because we had two teachers. That's
Okay,
why.
two teachers are teaching. Fine. So your exams are upcoming. Any exams are upcoming? Both of you.
Ma'am, I
Yeah.
have June 10 half yearly.
When you have fairs?
June 10 next month.
June. Okay. And you?
Ma'am, I have unit tests in June from 6th June and half yearly from 23rd June.
All right. Okay. So at least you have your exams in June. So we have the time for completion of syllabus. All right. So what we'll do, we'll start with the first chapter here only. And we'll slowly, now we'll have a very short class duration, right? Not today, but slowly we'll increase our class duration. So what will happen when our class duration will be increased? So the syllabus part will also go. And before at least your June, your exams, we should be able to complete these two chapters in the month of May. First and second at least. Motion in the plane we can start in the month of June. That's okay. And for your exams, I can take your extra class separately. There's no need to disturb the batch. See, we'll be studying theory portion, then we'll have the numerical. This is how we'll be going about in the class, and this is how I go. And everything will be done in the class. Everything will be covered in the class. You will be having your class notes here. I'll make the class notes in front of you. You will write all the things well. Some things are already discussed in the class that I'll just show you that I'll tell you right now only. And anything you want me to ask, anytime you can interrupt me in between. You can text me in the chat column. The chat column is constantly open for both of you, for all of you. You can always answer in the chat column. And best is if you can unmute yourself. That also you can always do. You can unmute yourself and get your doubts clarified.
Ma'am,
Next.
so we both are the separate batch, or you will join us?
Same. In the same batch, new batch will be started for you. From the starting only, I'll take your class. But some student in a new batch only you will be added. But some students have attended the introductory classes. So that's why you've been called half an hour before today, just to get the introductory part, what we have discussed, because I'll be starting with dimensional analysis, and you should be aware of that. Fine. And do not write down anything while I'm teaching. I'll give you sufficient time to copy down everything. So you'll have everything with you. And these notes are very important. So make these notes properly. Whatever portions will be missed, that I'll tell you. So in the first unit, we'll be starting with dimensional analysis. This is the most important part of this chapter. Now, before starting with dimensional analysis, before starting with any concept of physics, anything you both have any query regarding the class schedule or anything? How do we go about? So before I start with it. Anything? No?
No, ma'am.
No.
All right. Then let me start with it. So see, yes, one thing I've told you, that anytime you can ask any doubt, and just do not write down while I'm teaching. I'll give you sufficient time to copy it down. So you will have plenty of time. Now, before starting with anything, you should just understand that physical quantities which are present in nature, physical quantities which are existing, what is a physical quantity? The first question is, what exactly is a physical quantity? These are very,
Ma'am,
yes.
which can be measured. Okay.
Faiz, you're asking something?
No, ma'am, which can be measured is called physical quantity. I just said.
Okay. So yes, so when we're talking about the fundamental quantity, physical quantities, anything that you can measure, right now, do not write down anything. I'll give you time to copy. So that, and if you want me to scroll up something, scroll down, you want to see something, just let me know. And if I'm not able to hear you because the speaker is not working well in this laptop recently, so you can text if you think I'm not able to hear you and you've been saying something. So just text me in the chat column. I'm always reading your messages. And try to be active in the class. Try to participate in the class through the chat column also. You can do that, is already allowed. Yeah, so physical quantities are what? Something that you can measure. If I ask you, Faiz, what is your height? You can measure your height and you can tell me. If I ask Tayyabullah, what is the time right now? He can check the clock and tell me the what's the time. Or if I ask you your weight, you can stand on a weighing machine and tell me your weight. So mass, length, time, all these are what? These are physical quantities. Means some things that you can measure. These are the things that you can measure by us. Now we have two groups. We have fundamental quantities and we have derived. What is the meaning of fundamental? Something that is the base. That is the fundamental or the foundation. That is the base. And that will be giving rise to different quantities. So some quantities have no formula, like length. Have you ever heard of any formula that is giving rise to length? Or have you ever heard of any formula of time? No. You do not have specific formula for them. In fact, they are used in the construction of other quantities because these are fundamental quantities. These are intrinsic in nature. You have derived quantities then. Derived quantities means some things which are derived from the term only you can understand. Means in these fundamental quantities, when you insert mathematical operations, like I have length, I have time. Length is a fundamental quantity, time is a fundamental quantity. Correct, class? Now, if I divide these two, if I divide length divided by time, that gives me a new quantity, which is velocity. So velocity becomes the derived quantity. So fundamental basic quantities are present, then we have the derived quantities. So these are the basic, there are certain basic fundamental quantities and there are certain basic derived quantities. Derived quantities you don't need to even remember because there are numerous and hundreds of derived quantities. So many quantities are present. That how your syllabus, when your syllabus will be going on in the class, when the classes will be passing by, then in each chapter you will see these quantities present, their own formula. There we'll study in detail. Right now, I'm not going to the details of this. But fundamental quantities are essential. That should be done by you. Before I start with anything, syllabus you already have. Just write down this part. Just write down this part. Next, see, now let's see the fundamental quantities. So these quantities are those that cannot be expressed in terms of other physical quantities. These are called fundamental. This I have told you. Now see, SI system is a standard international system. Means this system is followed everywhere. So we'll also be following the same system. There are 7 fundamental quantities and 2 supplementary quantities which are present. All right. Seven, Fairs, I hope you're not asking something.
No.
Okay. So there are 7 fundamental and 2 supplementary quantities. Now these 7 fundamental quantities also you should know, and the supplementary quantities. Out of all the 7 fundamental, the first 3 are very important for your dimensional analysis. For your dimensional analysis, you require mass, length, and time. Mass, length, and time, these are the utmost fundamental quantities, and these are required in your syllabus and for the construction of dimensional analysis. So learn them properly, remember them properly. SI unit is kg, CGS unit is gram. CGS is also a system of units that is not a standard one which we follow. SI is the standard one. CGS means centimeter, gram, seconds. So this is only how you can remember. For length, you have meters or centimeters. Then for time, you have seconds. Now temperature, we represent it through the symbol theta or sometimes Kelvin. This symbol is also used. Theta or Kelvin. You can use any of these, but in most of the books, theta is also written. And in some, most of the books, sorry, Kelvin is written. In some books, you will find theta also. So do not be confused if you see theta. SI unit is Kelvin. CGS unit is degree Celsius. Then we have the concept of electric current. See, temperature, till temperature, you will study in class 11. Temperature portion is specifically there in your class second book. But electric current is a portion of your class 12. So do not go into the details. Just remember that if electric current comes, you have to represent it through A because its SI unit is amperes. Luminous intensity means the amount of light that is coming from a lamp or any source of light. And mole is amount of substance, you already know through your chemistry. So SI unit of luminous intensity is candela. But I have marked these two also. These are the least important. Luminous intensity and the amount of substance. These are the least important. So these are your 7 fundamental quantities. Then you have 2 supplementary quantities. What are your supplementary quantities? 2 supplementary quantities means you have the 2 types of angles which are present. The first angle is a simple plane angle that we draw in our notebooks. 2 lines intersecting and subtending an angle, theta. Sine theta, cos theta, we have been using this. This is the same plane angle. What is the new thing that you have to remember here is the SI unit. SI unit is radian. We have never used SI unit before until class 10th, right? In class 11th only we start with this. And since this is mentioned in your textbooks, and this is very important, this is radian. SI unit is radian. And then you have solid angle. Solid angle means something that is formed in 3 dimensions. Like if you have a cone, so the angle formed at the end of the cone is your solid angle. All right, this is your solid angle. So SI unit is steradian, steradian. Just add STE in front of the term radian. So it is steradian. This is the solid angle. This is something new. This we have not been using. And we do not represent it by theta. We represent it with this symbol, which we call it as omega. This will be representing the solid angle. And derived physical quantities, I've already told you, these quantities can be expressed in terms of fundamental physical quantities. Like you have velocity, which is length by time. Acceleration is velocity by. All these notes we have discussed in the class. That's why they are pre-written. Otherwise, in our regular class, we start and write everything. Like some basic definitions are already written. So do not worry about the things that I'm not writing something and the things are pre-written. These are this notebook is particularly the one that has already occurred in the other batch. So velocity, acceleration, force, all these are derived physical. Now we'll start with dimensions, but before that, just write down from here, start writing down from here. I'll scroll it slowly. Ali and other students, just wait for 5 minutes. Some students are noting down this. I'll start the class in 5 minutes. What you have studied. Muniba, you also have attended one class, no? One class only? Muniba, I think we have had a class.
Yes, ma'am, we had.
So how much portion was completed when you had attended the class, Muniba?
We had started with dimensions.
Okay, only that part was completed. Fine. See, let me start with that. Some portion Ali has attended in the last class. Never mind. Let us just discuss this part. It will be a revision for you, Ali. You have the notes with you. Then I'll start with the things in detail. Because see, these are still your introductory classes. Properly, I'll confirm also when your proper batch will be formed. From then, we'll continue from wherever we have left in these classes. Now, see, how do you write the dimensions? You just write the formula, and into the formula, whatever quantity is coming, that acts as your dimensions. Means if you have area as length into breadth, length will be acting as length, breadth acts as breadth, length. So you just write everything in terms of these fundamental quantities which are written. MLT. You have to write it in this term: mass, length, and time, and with their powers. So here L square is there. So mass is 0, time is 0, m to the power 0, L square, t to the power 0. That's how we write. Similarly with volume, this is length, this is breadth, this is height. So this is L cube. So length, breadth, and height is there. So this becomes L cube. So this becomes m to the power 0, L to the power 3, t to the power 0. And then you have, for example, density. Density, we had discussed, all these things were written in the earlier classes where you were absent. So see, density is mass by volume. Mass can be written like m, and volume is L to the power 3. So when this L to the power 3 goes up, it becomes L to the power minus 3. So the final dimensional formula is m to the power 1, L to the power minus 3. So this is how we have to write all the dimensional analysis. Let us see some more quantities, some other quantities which we have not discussed. But just other students, Ali and Muniba, just wait for 5 to 10 minutes. Let them just copy this part and then we'll continue with the dimensions part. Write it down from here. Affairs and Tayyab.
Okay, ma'am.
Alina and Ali and Muniba, just wait for some time. Just revise this, what we have discussed. Some new students are there. So let us just discuss the basics of it. Then I'll complete the other table that was left no in that class. Only one table we could just discuss. That I'll just revise it with you right now. And then we'll start with the next table which was left. Alina, is there any improvement in the numerical part of this dimensional analysis? Is it better now? Yes, ma'am. All right, we'll discuss it today. Just give me some time. All right. Written Faiz and Tayyib, have you written this part till here?
Yes, ma'am.
Okay. Understood. So how do we write this? You have the formula, and in that formula you start substituting. So Faiz and Tayyib, I'll discuss this table with you later on. Let me just revise it once. I'll give you sufficient time to copy it down. All right. So right now, Faiz and Tayyib, you do not write down this. Just understand and listen. So suppose we had started in the last class, I have told you all that you have length as the formula for distance, because for distance you have no formula. It's a fundamental quantity itself. So dimension was L. Speed, I have told you all to remember it, then only it will be helpful when you are writing the dimensions. Distance divided by time. So L divided by T, that becomes LT to the power minus 1. Then you have acceleration, which is velocity. Further, we are dividing it by time. We are getting L1 to T to the power minus 2. Then we had seen momentum. Then we had seen force was mass into acceleration. M into the acceleration. So it became MLT to the power minus 2. Work done, I have told you, it's the most important because it's same for all the energies which are present. So it's force into displacement, MLT to the power minus 2 into L. All right. And last was one pressure. Now, out of all these, I have told you to remember distance, speed, acceleration, force, and work done. These 5 things I have told you that just remember these 5 things. Rest of it, you don't need to even remember it. And whatever is the dimensional formula for energy, that you will get exactly the same for all the types of energies. Now we have to start from here properly. The students who have missed the above table, I think it's just fair, Tayyib. Muniba, have you written that table or it's missed by you also?
I didn't write, ma'am, but we discussed it.
The complete table you have not written.
No.
Okay, I'll discuss that with you. Then Muniba, Faiz, and Tayyib I'll discuss. Let's start from here, fresh. Other students, you can stay after the class. I'll discuss the entire table with you. It is just continuation of the table, so it doesn't matter if you're doing it above or below. You can just adjust. Just make this table in your notebook when I'll give you time. Right now, just understand. Angular displacement means, see, linear displacement is something which is done in a straight line. Angular displacement is there in your rotational motion. There we'll study in detail. And as I have told you so many times that you don't need to focus on the concept of the physical quantity. You have to just know how to write the dimensional formula if you know its original mathematical formula. Because about knowing about these individual quantities, you have separate full chapters on that and we'll be discussing it. Now see, angular displacement means the angle that is swept by any quantity. So we write theta as length of arc divided by the radius of arc. Length is also L, radius is also L. Why? Length you measure it as length only. And radius is also calculated as the length only. No? If I ask you calculate the radius of a circle, how will you calculate it? For the radius of a circle, you will calculate it in the same manner as you calculate distance, right? Because it's a quantity of distance only. So length gets cancelled and it becomes dimensionless. See, there's a very common question that comes in your class 11th is that name a quantity which has a unit but has no dimension. So from in that question which has no unit, no dimensions, you can give the example of angular displacement. Why? Because see, it's dimensionless but still has the unit of the angle. The angular displacement basically means angle only. So angle of radian is the SI unit of angle is present, which is radian, and it's dimensionless also. So this you can mention. This is a good case that you can add in your examples. The way we have linear displacement, we have linear velocity also. We have linear angular velocity also. So angular displacement was 0 L to the power 0. So we only have time in the denominator. So this becomes T to the power minus 1. SI unit becomes radian per second. So see, just write this till here. Till acceleration, let me or just wait, even before acceleration. Acceleration, you all answer. Just write it till here. And I'll tell you the formula. First, copy it down till here. Make this table. Now see class, the next is angular acceleration. So what is angular acceleration? I'll tell you the formula. Angular acceleration, this is angular velocity, this divided by time. Tell me what would be the dimensional formula of angular acceleration. It is this angular velocity divided by time. Quickly answer in the chat column, all of you. Just answer in the chat column. Alpha is angular velocity by time. It's very easy, you'll be able to write it. Yes, perfect. It's t to the power minus 2. See, angular velocity is already t to the power minus 1. Look class, you have this as t to the power minus 1 and then you divide it by t further. So you get t to the power minus 2. This is absolutely correct. Then the next quantity is moment of inertia. Moment of inertia, this means this is something like mass. The way you have mass in your linear motion, no, you have moment of inertia as the rotational analog of mass. Again, this you will be doing all these things in rotational chapter. Do not worry. You have rotational as your 7th chapter. Go by the formula. Formula is mass into radius square. Mass is just m. Radius square means L square. So this becomes m L square t to the power 0. That's it. Write down these two as well. Write down 10th and 11th as well. Class, tell me the answer of the next one. Others also, please try. You have torque, something. Torque is the rotational analog of force. Formula I'm telling you, tell me the dimensional formula. It's force multiplied to the radius. Force multiplied to the radius. Now tell me the answer of this. What would be the dimensional formula? Force into radius. Force into radius. Okay, Ali has answered also. Very good. Others also, please try. Force, you all know. Alina, some things are missing. Just check. Yes, very good. So Tayyab has answered it correctly. Muniba has answered it correctly. Alina, just one letter is missing. Ali has already answered it correctly. Correct. See, you have to multiply force into displacement. So force is mlt to the power minus 2 and just multiply one length. So length will just become square. This is the difference that will come when you're talking about torque and force. Alina, check the mistake. What have you done? Force is this. You are just multiplying length. L square, not just L. L square it would be. Clear? Is it clear, Alina? Fairs clear?
Yes, ma'am.
All right. Now, see, angular momentum is what we have studied. You can copy it later. I'll give you time. Just listen class first. You have angular momentum. Angular momentum is linear momentum into radius. What was linear momentum? Linear momentum was mass multiplied to velocity. So mass multiplied to velocity gave us linear momentum. Now we'll multiply this further with the length. So that becomes L squared. So just one more. In the rotational components, just one radius is being getting multiplied. And the next quantity is stress. Stress is very easy. Stress is force upon area. Can anyone who remembers tell me, was there any other quantity that was force per unit area? Force by area. If you can recall from your lower classes as well, force by area. Not mass. No, that is F is equal to ma. That A is acceleration, not area.
Pressure.
Pressure. Very good, Tayyib. This is pressure. So stress is actually similar to your pressure only. In physical terms also it is similar. This you will study in your second book. All these things are there in your syllabus. This is there in your second book, bulk properties of matter, solids. There we'll study this. But the point here is that everything is similar as pressure. Why? Because the formula is same, force by area. So force getting divided by area, this is the exact formula of pressure that we have received. Pascals per pascals per Newton meter. Write down these three first, 12th, 13th, 14th. Next quantity class is strain. Now strain means change in a dimension by original dimension. This let me show you. So change in, suppose you have change in length by the original length. So what happens here? Length gets cancelled. You have no dimensions and it has no units also. Why? Because see, here also you have meter as the SI unit. This also is in meters. So both these units get cancelled. Now the second question that can arise. First was a quantity that has no dimensions but has a unit. That is your angle. A quantity that neither has dimensions nor has units. It's strain. No dimensions are present. It's unitless as well. No units and no dimensions. Write it. The next quantity is modulus of elasticity. This I'll tell you. The next quantity you will tell me. So this is stress divided by strain. What was stress? Stress was pressure. Was strain anything? No. Stress didn't any dimension. It had no units. So here, if strain has no role, it's zero. So whatever are the dimensions of stress would be the exact dimensions of modulus of elasticity. So see, it's again stress divided by strain. So you get this term as it is. So pressure, stress, modulus of elasticity all have the same formula of a dimensional analysis. Write it down. The next quantity I'll tell you. You will tell me that. Or let me just tell you. Next quantity is surface tension. This is force per unit length. Tell me this. This is very easy. All of you should answer this. Okay, only till now, two students have only answered, Muniba and Tayyab. See, force, you already know, all of you know what is force. You have seen here only. This is the formula of force. You just divide length. So this length would only be cancelled. No, rest of it would be same. So Tayyab has answered it correctly. Very good. See, you are just writing force divided by length. So see, force is this, you're dividing it by length, so LL would be cancelled. You will just have mt to the power minus 2. Now, wavelength is the length of a wave that you study in SHM and waves. So the length is just, it's just the length. Wavelength is just length. So that's why you have the unit as the dimensional formula as L and your SI unit as meters. And time period means the time period means something that has to be completed over a cycle. So this is also, all these are part of your, this was part of your fluids. All these are parts of your waves and SHM chapter. So time period is just time. Frequency is 1 by time. That's why frequency is t to the power minus. Write down this page as well. T class, this is Planck's constant. Basically, energy is equal to, this is Planck's constant into frequency. So what would be the Planck's constant? Energy divided by frequency, correct? So energy's formula, I've told you, it's the same formula of work done. That is m L square t to the power minus 2. Divided by frequency is t to the power minus 1. So when t to the power minus 1 will go up, this will become t to the power minus 1 here in the numerator. Temperature is a fundamental quantity. So it's theta or K. Heat energy, I have already told you that it's the same exact that of energy, that is m L square t to the power minus 2. This is exactly the same as that of work done. A work done portion has been missed by some of you. I think Faiz, Tayyab and Muniba. That portion I'll discuss with three of you later on. Right now, let us just complete one last quantity that is left is specific heat. What is specific heat? This is a topic of your second book, thermal physics. Basically, specific heat is the amount of heat that is used or that is generated when a substance temperature changes. So this is mass into specific heat into temperature. So what would be your specific heat? Heat divided by mass divided by temperature. So this is heat energy divided by mass divided by temperature. So mass would be cancelled. This will be m to the power 0, L to the power 2, T to the power minus 2, K to the power minus 1. Write it till here and just text me done once completed. All right, class, if you have completed till here, you all can start leaving. In the next class, I'll continue from there. And I'll call you all earlier. Faiz, Tayyib, and Muniba for the portion that has been missed. Otherwise, you all can leave anything if you want to ask. I'm there. Otherwise, you can. Thank you so much, class.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.